Alright, this is Ken Roosevelt. We're going to do some problems from Alex. These are standard normal probabilities, and you can do them a number of different ways. You can use some of the applets I've linked to. You can use the Alex calculator. You can use the table in the book. However, or you can use your TI calculator. I will say this though. When you have your final, you're only going to be able to use either the table, the Alex calculator, or a TI calculator that you bring with you. You won't be able to access other websites. So I show you those other websites so that you can check yourself. You can see some other options on how to do it, but I really want you to know how to calculate it by hand, and those websites take all this thinking out of it. So I don't want to relieve you totally of understanding. So I do want you to do a little more than just plug it into one of those websites and have it spit out the answer. But you can certainly use them to check your answer. So let's do this. If you're looking for the probability of finding a z-score on a specific value that is less than or equal to 1.93, one of the ways you can do that is you can look up 1.93 in a chart. When I see p of z less than 1.93, right away I imagine a picture in my head. And the picture I imagine looks kind of like this. I see a normal distribution, and on that normal distribution I see 0 here. This is the mean. I see 1, standard deviation is right there. I see 2 is there. So 1.93 would be right about there. It would be very close to that. So I'll call this 1.93. And when they ask me for p, the probability of finding a z-score that's less than or equal to 1.93, I think of everything to the left of that value being shaded in. Forgive me if my shading is not perfect, but everything there will be shaded in. And what it's actually asking me is what percentage of the data is green right now. Okay, what percentage of the area? We know anytime we answer one of the questions, the answer will be between 0 and 1, between 0% and 100%. We're going to have a decimal here. Two ways of getting it. I can use the Alex calculator. I'll show you that in a second. I can also use my table. Okay, I have those tables here. So 1.93 is greater than 0, so I would use the table that's found on page 645. That's this table here. And to find 1.93, I will look in the 1.9 row, which is right here, and the 0.03 column, which is right there. And when I do those two things together, I get that value right there, 0.9732. Okay, so it's pretty straightforward. It's not hard to use a table. Let's do it now with a calculator. So in Alex, if I want to find z, it's on the left, the probability of z to the left of 1.93, a calculator. I'm looking here, p of z left, and you notice that the picture there matches the picture there. Okay, this is where I copied and pasted this from. It's page 645. Okay, matches the picture down at the bottom, because we're looking for the left-hand area, the area to the left of that z value. So we got to use none of these other ones because those pictures don't match, right? We want this one right here. So I hit that, and what do I type in? 1.93. Very simple, and it gives me 0.9731. 0.9731. What did I get using the table? Let's go back and look. I got 0.9732. So they don't match exactly, but they match pretty close. All right. Let's look at... Let's look at the next one. Okay, the second question, we've already figured this one out, so that's done. P of z greater than negative 1.95. Here's 0. Here's negative 1. Here's negative 2. So 1.95 is virtually right on top of negative 2. So that's right. We'll just say right there. That's as close as I can do it. And because it says we want the probability of finding z-scores greater than that, we are interested in the area to the right of that. So all this area over here. And I'm shading in blue. The only problem is both the chart and the calculator return areas that are to the left. So there's two ways of doing this. One is we can use the symmetry of the graph. If we're interested in this area over here, then it would be the same as taking positive 1.95 and finding its area because of the symmetry. So we could look up positive 1.95 using P of z less than or equal to 1.95 using the symmetry. The other option would be to find P of z less than or equal to negative 1.95, which is this magenta area, and then subtracting that from 1. So we could do 1 minus that would be equal to P of z greater than negative 1.95. Does that make sense? These are complementary of one another. If this is A, this is A complement. Okay? So if I want to find P of A, I can do 1 minus P of A complement. So let's do that first with the table. I'll use the symmetric approach because it's the easiest. I'll do that first. So I just look up on the positive table 1.95. Here's 1.90. 1, 2, 3, 4, 5. 0.9744 is my answer. My answer was 0.9744. Other option was to take P of its complement, which is less than or equal to negative 1.95, so I can look that up on the table. On the negative side, I look up negative 1.9, and 95 is right here, and it's 0.0256. So I can go back to here, and I can go 1 minus 0.0256, and I get 0.9744 again. So either way works. And it's up to you which one you want to do with the calculator. Doing it with the calculator is very easy as well. If I hit this button, then I better put in the positive 1.95 using the symmetry, and there you see it once more, 0.9744. However, there's no reason I can't go 1 minus this and use the negative. And that's it. Okay. Last one is for between. I don't know if I have time for that, but if I don't, I'll split the video and I'll be on the next one.